All right, so now we're going to look at using our calculator to find some of these. And so I'm going to go ahead and graph this function because that's the first thing it tells me to do. And I'm going to show you how to put in domain restrictions in your calculator. So I'm going to go into my y equals. And you can see I've already put this in. So I've got my 3 over 26 times x minus 1 squared. And then what I'm doing is I'm using some logic down here to help restrict my domain. So I've divided by x is greater than 2. So I got this symbol going into test. And then under the test is where that symbol came from. What this means is that if this is true, it returns a value of 1. So if x is greater than or equal to 2, I get a value of 1. So dividing by 1, that stays the same. If it's false, it makes 0. So dividing by 0 causes undefined. So I want x to be greater than or equal to 2, and my and came from the test again, but now in the logic menu. So I want and x is less than or equal to 4. So as long as both of those things are true, it will return 1, and I divide by 1, and that works. Otherwise, it returns 0. I divide by 0, and I get an error. So I can come and see this in my table. So I've got errors everywhere except for x equals 2, 3, and 4, and of course every point in between. I can see that my maximum, it looks like this is an increasing function, so my max is at x equals 4. Let's see if our graph agrees. So I've set my window to go from 0 to 6, just to sort of see around this. My y max, I saw that that went above 1, so I'm going to go ahead and increase this a bit. Maybe I'll call it 1.4. And we could count by 0.1s. All right, so if I look at this, there is my function. So like I thought, it is increasing. Let me copy this and put it over here. Okay, so there's my function. All right. Oh, goodness gracious. All right, make it a little bit bigger. So here's my sketch. Everywhere else my function is 0, so I would like to include that on my picture. So I could draw in 0, preferably on the line, to indicate that it's not true at the 2 and the 4. I could circle those because at 2 it's this value and at 4 it's this value. So there's my sketch. My mode happens at x equals 4 because that's where the maximum is. Probability from 1 to 3. Well, I know the probability from 1 to 2 is going to be 0. Probability from 2 to 3 is going to be this region here. So there's my 2, there's my 3, so I want this area. So what I'm going to do is I'm going to come into my calculator again and come back to the home screen. If I go into alpha window, I can see my fn int, and it gives me my setup. So I'm going to go from 2 to 3. I'm going to type in my function. And then I'm integrating with respect to x. Notice here it defaults to alpha. So get it alpha of alpha so that you can do your x. Ooh, this doesn't make sense. It's greater than 1, but I can see I missed my 6 in my 26. So let me come back and insert that. All right, so insert a 6. That makes much more sense, about 0.269 or 26.9%. So I could say that integral from 1 to 2 of f of x dx plus integral from 2 to 3 of f of x dx So I can divide up my integrals, no problem. It's just like adding separate areas like I did before with rectangles and triangles. So I get that the probability from 1 to 3 is about 0.269. Expected value, I come back to my calculator, and this time I'm going to go from 2 to 4, and I want this whole thing times another x. So expected value is x f of x across the whole domain. So I need to go from 2 to 4. All right, so my expected value, about 3.3. That makes sense because from 2 to 3, my probabilities are only increasing, so I would expect to see 3. So E of x is going to be integral from 2 to 4 x f of x with respect to x, and that was about 3.31. Finding the median is a bit trickier because now I want to integrate my function and have the probability be a half. So I'm going to come in and put my integral in to my y equals. So this time I'm going to say alpha y equals, function fn int. I'm going to go from 2 to x, and this time, since I've made this my x, I'm going to say 3 over 26 times, I'm going to put in a different letter this time, a minus 1, and we'll square that. And then I'll integrate with respect to a. This time what I'm looking for is my x, and I want my integral to be equal to 0.5. So I'm going to graph this. We know that when x is 4, that's when I should end up at 1. So, and we know that from 0 to 2, I'm ignoring everything because it really starts at 2. We'll talk next year about why these values would be negative for less than 2. And so we can see this is it's taking quite a bit. Think. And then we'll find the point of intersection is what's going to happen next. So we need it to keep going, and maybe I should have again stopped it at 4 so that it doesn't take so long to think. On a test, of course, you would move on and be solving a different problem while you're waiting for this to calculate. But here we go. Still finishing up here. Some point soon it's going to draw in my y equals a half. Come on, calculator. You can do it without freezing, I hope. All right, so we're going to find our point of intersection to find our x value. So calc, intersect, y1, y2, and it looks like it's happening just a little bit to the right of here, maybe 3.2. And oh my goodness, you get the picture. Oh, there we go, 3.41 is where our median happens.